Before we get started and look at some series parallel circuits, you should know how some of the basic circuit components function, such as how a resistor operates in series and parallel formats. You should also know about Kirchhoff's circuit laws, along with the voltage and current divider rules. They'll make the complicated circuits that much easier. If you're not sure what I'm talking about, just remember that the test is in 3 weeks. After spending the last 2 days cramming this topic, I've carefully selected the best examples to introduce you to series parallel circuits. First, we'll begin with an easy example that I handcrafted. It's actually just one from the textbook. When looking at a circuit diagram like this and attempting to find the source current, a great method is to simplify down the circuit. As resistor 3 and resistor 4 are in series, you can simply add them together. I usually denote the resulting resistance with another character. Personally, I like the apostrophe, as it reminds me of the tears of my enemies. Once you have R', you can imagine that the circuit now only has 3 resistors, and we can see that resistor 2 and resistor dash are in parallel. As a result, we can easily combine and replace them. We'll call the total R''. A good fact to know is that when adding resistors in parallel, the resistance will always be smaller than the smallest resistor in parallel. We're now left with a simple series circuit with just 2 resistors. We can add these up and find R total. And to calculate the source current, we apply Ohm's law. Simple. To calculate I3, it's a little bit trickier. Firstly, we know that the current through I1 will be equivalent to I source, as the current in series is the same. Now you could do KCL, but in this case, it'll take too much effort. A great tool to use is the current divider rule. Now the formula of the circuit is set out like this. And it's tempting to say that you just multiply the total resistance of the circuit and the total current of the circuit and divide by the resistor of the current branch you want, and you'll be on your merry way. Wrong. In this case, we want to see how the current divides between the 2 branches. So RT is actually the total resistance of R' and R2. You ignore R1 as it's already in series, and Rx will be R'. To calculate V2, we need to know that the voltage across parallel elements will remain the same, and that the voltage will only drop across series resistors. Knowing that, we can imagine that the circuit only consists of 2 resistors, R1 and R', because the voltage across R2 and R' will be identical. Thus, we can easily calculate V2 using the voltage divider rule as such.